This is our fluorescence instrument. So I want to take you through a quick introduction to the fluorescence instrument, and then show you how to use it using the computer software. So a lot like the absorption instrument that we looked at last week, we have a light source and then a wavelength selector. Now, with the fluorescence instrument, we're going to have two wavelength selectors, one before the sample and one after the sample. Okay? I'm not going to take the lids off because this thing needs to be sealed up a little tighter. Okay? With fluorescence, like all photon lives matter. Okay, so we need to really keep track of fluorescence of the photons. It's a much more sensitive technique than absorption. So one of the consequences of that is that you really have to have everything buttoned up tightly. So you can see when I pull the lid up, we've got a box in the back. Come on up around this, guys. We've got a box in the back that contains the light source. And when we fire up the light source, you're going to hear a buzz. And the buzz is the light source kind of strobing on and off. It's like a strobe light going really fast. Okay. The light source comes into a wavelength selector for excitation. And the excitation light is going to come out this way. Okay. I'm not sure if this is on right now, but we might be able to see the excitation light. Nope, it's not going. Well, yeah, we don't have the buzz going. We don't have the light bulb on. But it's going to come out this way into our cuvette holder. Okay, so our cuvette holder is going to be right here. So the excitation light comes in one direction, and then it's going to excite something in the cuvette, and the excitation or the fluorescence is going to come out another direction. The fluorescence actually comes out in all directions. We just choose to detect it in that right angle. Right? So it's not like molecules know about right angles. You just pick a spot to detect it. So then light that is fluoresced comes this way, goes through a whole other wavelength selection area to a detector, which is back here. And like I said, all of these things are carefully buttoned up so that no light gets in there except what's from the source. Right? And even with that, the detector is keyed into when the light bulb is on and when the light bulb is off. So like fluorescent lights will kind of oscillate at 60 hertz, okay, with electricity. So it'll be able to distinguish between the frequency of oscillation for the light bulb and the fluorescent lights. Here's my cuvette. So the cuvette, I don't know if you can see this or not. Eventually you'll get a chance to take a look at this. It's got thin windows on this side, kind of a slit, and then on that side it's got a wide window. So your excitation comes from the small parts, and the fluorescence comes out the big parts. When I put this in, I always set the logo to be facing the excitation beam. Okay. So that way then I'm sure that I have an open window to the excitation light and also an open window to the fluorescent light. Does that make sense? When you do fluorescence stuff, since it's much more sensitive than absorbance, we're going to have really small concentrations. So this machine, for something that fluoresces well, this machine can detect down below a nanomolar of concentration. Okay, so you want to be prepared to dilute. Oftentimes, when spectra go wrong or things go badly, it's because we just have too much sample in there. Okay, Now, because it's so sensitive, we also have a couple of things that we can use to control the light. So those are down here. At least they used to be. I might have to go find them. We have some optical filters. I'm going to go out to find them. Maybe we can edit this part out of the video. Pretty sure there will be no video editing happening ever. Okay, so how do we operate this thing? Well, first the light switch, or the power switch is back here. Okay, and when we approach the computer stuff, let's go ahead and pause this and then switch over. So to run this instrument, we're going to use the same computer that we did with the UV Viz. I set up a new user account so that if this computer is ever logged out of, you can get into it. The username is cleverly user with a capital U. Okay, and the password is chemistry, all lowercase. Okay. Now you do have to select on the domain part. You do have to select this computer, not post office. So it's just accessing this computer. It's not going anywhere else. But now it'll allow you to access both the UV Viz and then the fluorescence. Does that make sense? The software for the fluorescence instrument is called FL WinLab. All right, that's as opposed to UV WinLab. So we're going to click on FL WinLab. We want to make sure our machine is powered up beforehand. It's going to take a little while. Did I click on the wrong one?
You clicked on UV.
That's the drugs. Sorry. FL WinLab. All right. So FL WinLab is communicating with the instrument. It turned on the light bulb. Okay. This software is super old school. Okay. So you can see kind of the interface looks a little bit old. Let me show you some navigational stuff. So all the icons up at the top do things. You want to zoom in on that, Mitchell?
Can I zoom in on this camera or like?
You can extend your arm.
All right. I'll sit right here.
I'm sure you can also zoom in. Let's just make this as awkward as possible. That's fantastic. The icon that looks like the instrument, if you click on that, it will show you what all the settings are like. Okay, so starting with the light source, it tells you right now, it's telling you the light source is on. Then we're selecting out a wavelength. Currently, it's 420 nanometers with a slit width of 5. Okay. Then there are some potential filters or polarizers in there. The sample accessory actually has a stir. Okay, so you can stir things. Super neat. That is off. And then information about the detection end of things. The detector is on. And so if you want a snapshot of what the instrument is doing, that will tell you. Okay, we can X out of that. If you hear the buzz, that means the light is on. If you don't want it to be on, we can hit this light bulb icon and it'll turn it off. Okay. On, off, on, off. Okay. So now we want to do a measurement. We want to select out a measurement called scan.meth. Okay, meth is short for method, not methamphetamine.
never know.
You never know, right?
Yeah.
Scan.meth. So we're going to open that. And now we can set up different things. So it automatically turned the on our light bulb. So suppose we didn't want the light bulb on, we could turn it off. So now we can set up our scan. Now I've got this set up to do an emission scan, and I'm going to have the excitation wavelength. I'm going to put it at 420. Okay, and I'm going to start scanning the emission at 440, and I'm going to end at 750. Okay, and my emission slit and excitation slit are 5 and 10. Let's just keep that the same. And the scan speed, I'm going to make that 1,000. That sound okay? Now I don't want to just scan once. I want to scan several times. So I'm going to click on the average. So this button gives us a chance to scan a bunch of times and take an average. This scans just once. These different ones, like this one, repeats it after a while. Different things. Okay. I'm going to have it scan 10 times. Okay. All right, so let's get a sample set up. So I'm using tartrazine, and I had tartrazine in there a little bit earlier, and what I found was that my solution. Oh, yeah. The tartrazine that I put in there was not concentrated enough. So what I'm going to do is I'm just going to pull the solution out of the cuvette using this cute little pipette. Okay. And this cute little pipette actually reminds me of Sean, who wrote this protocol. Just a dainty little thing. I'll make sure you tell him to watch this. He'll appreciate being called a dainty little thing. All right, so we're going to pull that out and dispose of it there. Now the reason I've gone to this small pipette is that the geometry of the cuvette is actually pretty narrow in there. So to get down to the bottom.
Do you want to clean this cuvette like the others with like acetone or like a Q-tip or something?
You do. I think the best process is going to be just when you're done to always make sure you rinse it with distilled water, like pretty quickly. Generally, things will not need to be really cleaned unless something dries in there. So if you finish your sample and then you go away and your tartrazine solution dries inside the cuvette, then the next person is going to have to do a really good job. Okay. But as long as it stays wet and you're just continually rinsing, that's fine.
I don't know if water would affect it like UV vis would, or have they?
Yeah, for this one, you actually don't end up doing background spectra, generally. Now, there might be some experiments where your background fluoresces, but that's not common. So I'm going to drop some more concentrated tartrazine in there. This cuvette only takes about, you only need about 200 microliters in order to fill it. Okay. So I just put a good squirt in there. It's more than full. It's overly full. More than we need. So I'm going to put this back in the instrument. Again, we'll put the fancy P toward the excitation light. And we'll close it up. Okay, so now I've got my excitation wavelength. I've got my emission wavelength that we're going to scan. So we're going to fix the excitation, and we're scanning the emission. Okay. There are some subtleties here. Notice how my excitation is less than the area that I'm scanning. Okay. So we're going to hit it with 420, and we're going to see if it fluoresces at 440 and above. Okay. You don't want those two ranges to overlap. So if we're exciting at 420, we don't want to look at 420 for fluorescence. We'll just see the excitation. Okay. So you want to make sure that those things are well separated. Now it gets complicated because we're exciting at 420 with an excitation slit of 5. Okay. So think 420 plus or minus 2.5. Right? And we're starting at 440 with an emission slit of 10. So think 440 plus or minus 5. Okay. So you don't want those plus or minus ranges to overlap or even to be like super close. If you mess that up, you'll notice it with your spectrum. It'll look super weird. Okay. So let's go ahead and do this collection. Now to start your experiment, you just hit the green light. Okay. And let's do that, and we'll see if the light comes on. Okay. Has the light come on?
No.
It is collecting already. Look at that, it's collecting. So let's stop it and turn the light on, and now we'll hit collect again. Okay. All right, so I can't tell if it's doing anything. Let's hit auto scale. So there's some buttons up here. We can auto expand the left and the right axis. That looks like a mess, doesn't it? Looks like a mess to me. We are doing something wrong. So we have to figure out what's happening here. But it's gonna keep on collecting. Now the jiggles up and down are an indication that it's really not getting any light. Okay, so there's really not much light hitting the detector. The detector in this instrument is something called a photomultiplier tube, and the photomultiplier tubes kind of crap out about 600 nanometers or so. So to correct for that, they get less sensitive the further red you get. So to correct for that, they kind of multiply things by a factor. Okay. So we're getting just a couple of photons out further to the red, and it's kind of multiplying all of that and giving us just a bunch of cabbage. So let's go ahead and we'll stop this.